Hello, welcome to this overview of the enhanced heat and inseminator models in our eFarm Django application. My name is Peter Evans. If you're new here, don't forget to hit that subscribe button and also ring that notification bell. So as we delve into the intricacies of these models, you'll gain insights into how they have evolved better to serve the needs of our dairy management system. First up, our newly updated heat model captures the crucial observations in the reproductive cycle of our cows, and this model shall include the observation time, which is a daytime field record for the time of the heat observation, as well as the cow, that is a foreign key linking the heat observation to the respective cow. And in this model, we shall have our clean method within it that shall handle the comprehensive validation checks before saving the heat records, just like the other tutorials and how we are validating them. And these checks shall ensure that the observations falls within appropriate timelines and aligns with the cow production status, pregnancy status. Moving on to the inseminator model, we've revamped it to encompass a comprehensive set of attributes for managing inseminators responsible for the cow's insemination in our farm, and it shall have fields such as the first and the last name, the phone number, the sex, the company, as well as the license number. And in conclusion, these enhancements are designed to empower our eFarm app with more accurate, comprehensive, and user-friendly functionalities for effective dairy farm management. And without wasting much time, let's jump straight into our PyCharm editor. Over here, you have the inseminator and the heat models open for us, ready to explore. The inseminator model has 6 fields, that is the first and the last name, which are both character fields of maximum length of 20, and the phone number, that is a phone number field from the package Django phone numbers, so it's being inherited from the phone number field.model fields module of the same package. Then the sex, which is a choice field from the sex choices. The company is a nullable field. You can see blank is equal to true, null is equal to true. So the rationale over here is that some inseminators operate on their own and they do not work under any company. So it makes sense that some people should have their company as null or blank, yeah, just like that. Then the license number, of course, each and every guy who is doing the artificial insemination, at least in my country, must have the license number. That could be the same case in your country as well. And then proceeding to the heat model, it has just 2 fields, that is the observation time, which is the time of the heat observation, and the cow field, which is linking the cow that is associated with the heat observation. And so this model, heat model, has an arsenal of validators, that is the validate observation time, validate the dead cow, validate the gender, validate already in heat, even validate the minimum age. So you already know where we are headed to, that is jump straight into our validators.py. Yeah, over here, this is the class that contains all those methods. So first up, the validate observation time ensures that the observation time is not in the future. Then we also validate the pregnancy status of the cow. The cow must not be pregnant because there's no way pregnant cows can have heat records. And then the production status of the cow must be open. So the open term is often used in the dairy parlance, or rather in the livestock industry, to signify, or rather to notify that cows which are actually ready to be bred. And then validate already in heat actually ensures that there is no any heat record that is associated with that cow within the past 1 day. If that's the case that is violated, then the cow already in heat within the past day error shall be raised. Then we also ensure that the dead cows and also the male cows do not have any heat records. And then we also validate that within 60 days after calving, a cow must not have any heat record, because we want that sometimes a cow has some sort of, let's say 2 months of rest, is when now it moves on to the next breeding cycle. So here is how it works. First of all, we check if the cow has any associated pregnancies, that is using the syntax cow, not pregnancies, not exist. So you might be wondering, by the way, that Peter, in our cow model, there was no any field that is named pregnancies, but hold on, let me just take you back a little bit. In our models.py, in the pregnancy model, we had this related name, cow.pregnancies. So this way, we can actually check the pregnancies that are associated with this cow just by the syntax cow.pregnancies, because these are related name. If we did not do that, we could as well just use the cow.pregnancy underscore set. So those are 2 ways of actually doing the reverse query. So we check, this one actually shall return a Boolean flag if the cow has some associated pregnancies. And then if that's the case, then we now perform this. First of all, we check if the cow's pregnancy status is calved. technically, if the cow has given birth within the past 60 days, then its pregnancy status shall be calved. And if that's the case, and the observation time minus the date that it had calved is less than 60 days, then we shall throw this error. And then we also validate that within 21 days, there's only a single heat record, because cows are always in heat between 18 to 24 days, averagely 21 days. So there is no way a cow can be in heat today, then after 10 days, it's also in heat. That one cannot happen. And last but not least, we validate the age of the cow to ensure that only cows which are above 1 year old can have heat records entries. And so that's it for our validators.py. So let's head over to the serializers. And in our serializers over here, you can see we have the heat and the inseminator records. So these are pretty much simple. You can see we're just serializing everything over there, and there's no any special code over there. But wait, we have this create and the update method. The update method is very much verbose, so we'll have to refactor it, as well as the create method. And one thing that I've realized, by the way, from our previous implementation, that is in this try and except cache block, you can see we are performing 2 SQL queries, and that's not actually optimized. You can see over here that we are performing the cow breed objects get. That is one SQL query. And also, if the cow breed does not exist, we are also now performing another SQL query. So that's not optimal. So we shall need to refactor this, as well as the update method. So while this is very much verbose and I know it's so good, I think sometimes being too much of a verbose is not really a good thing. So shall go ahead and actually just refactor all these two. Yeah. And right now you can see that just by performing the get or create method from the objects manager, so we can just send a single query and it will actually retrieve the breed if it's actually there, or create a new one with the same breed data that is actually passed through over here. And similar to the update method, so we shall be using the list comprehension, where we'll now be looping inside the items inside this list, then we pop them out and then call the parent update method to actually now do its stuff. So that's it for our serializers. So we then head over to the permissions. So today we have some new permissions over here, that is they can add heat record. So we shall allow everyone to add heat record in our farm, that is the farm owner, the farm worker, farm manager, assistant farm manager, and then can view heat record as well. We shall allow everyone. So they're just pretty similar, but maybe we shall need to refactor them in future if need arises. And then can update and delete heat record. We only allow the farm owner, farm manager, and assistant farm manager. So that is the farm management, and if that's violated, or maybe that person does not have sufficient rights, we shall throw this error of only management have permissions to update and update and delete heat records. And then can add inseminator record. So this one is only restricted to the farm owner, farm manager, and the assistant farm manager. So pretty sure that right now you already understand the way we are performing our permissions. So let's head over to the views.py. And in our views.py, this is our heat view set. Over here, you can see we are also activating the filtration and then the ordering. So the filtration shall be performed based on the whatever is specified inside our heat filter set. And then we shall be ordering based on the observation time. So if a create action is passed to our view, then it shall apply the permission of the create heat record. And then if the action is either updating or maybe deleting, then we shall apply the can update and delete heat record. That is, this one shall only allow the farm management. Then if it's something like, let's say, viewing or listing, then we shall allow everyone to see that. And then in our list method, first of all, since we are now applying the filtration, we have to account for the fact where if the query parameters that are supplied to filter the heat objects in our database is actually returning anything, and if it's not returning anything actually, of which that is the case here, if not query set exists, we shall return this no heat records found matching the provided filters, or if basically there is no any query parameters that is associated with that request and we have not actually added any heat record in our farm, then we shall throw this message, no heat records found in farm yet of status http 200 okay. And if there's some data over here, of course we now pass the query set to the serializer to serialize it, and we specify many true because it could be several heat objects in that query set. And then for the inseminator view set over here, you can see as well, we are activating the filtration and also the ordering. And then since we only had a single permission, so we just apply directly like this, that is, they can act on insemination record. And this is actually only limited to the farm management, that is the assistant farm manager, the farm manager, as well as the farm owners. So we do the same thing in the list method, just like what we've done in the Heat view set. And then now that's it for the views.py. So maybe just to give you a quick glimpse of whatever we have in our filters. So we shall be filtering based on the observation time. Then for the inseminator filtration, we shall be doing that based on the first and the last name. And at this point, I feel like that's it for the main part of this tutorial. So we shall head over to test whatever we've actually introduced today. So remember, we have in our base test folder, the dairy, and then now the tests here. So let's head over to the test.py. So over here, you can see there are very many tests. So let me just get up a little bit. Okay. Okay, now you can see we have the test heat view set. Let me just collapse it a little bit there, as well as the test inseminator view set. So first up, we are testing if we can add a heat record as a farm owner. And by the way, remember from the previous tutorial, this is the way how we avail the authenticated and the logged in users. So in this case, for example, the self farm owner token shall store an authenticated and a logged in farm owner. So that's what we are using over here, by the way. And what we are doing over here is just availing the heat record data and then now sending a post request to this URL. Of course, the reverse shall resolve the URL, that it will be the local host /dairy/heat and the rest. So then the request payload shall be the heat data. Of course, it shall be the observation time that we've defaulted to time zone now, and then the cow's ID. So the cow's ID, this is the cow that we are creating. And by the way, the cow must satisfy all those validation checks. If there's an error in between, or maybe let's say the cow is less than 1 year old, then this one shall not work and we shall have that error. And then now the format shall be the JSON format. And then in the previous tutorial, by the way, I was just passing the headers bluntly over here, but I realized after updating some of the packages and the models in this project that doing that was now leading to some errors. Actually, the user was not being authenticated. And so passing this explicitly as HTTP authorization header here was the one that's working. So that's the case over here. So we passed the token for the farm owner and then assert that the response status code is 201. So we can as well just write the status.http 201. They just resolve to the same thing. It's only that that one is a more human readable thing. And then now you can see we also test for the addition of the heat record as a farm manager. That is the only difference, by the way, between this one and this one is only the token over here that is passed. So these are just the same. So let's head over to the inseminator view set. So the same principle applies over here. We also supply the tokens, and you can see over here we send a post request to this URL. The request payload is the inseminator's data, then the HTTP authorization over here, because this is testing about the farm owner. We supply the farm owner's token, and then we assert that the response status code is 201, as well as also check if the inseminator object is also in the database. Then now I'll just proceed to the very last part due to the interest of time, because these tests are so many. So let's say we are testing the deletion of an inseminator without authentication. You can see over here that we are now sending a delete request to this URL with the primary key of the inseminator that's supposed to be deleted, and then we assert that the response status code is for one unauthorized, as well as now the inseminator record is not actually deleted and it's still existing. You can see that's what this resolves to. And so that's it for the tests for today. You can as well go ahead and play around with the others. That is, you can even tweak the fixtures and see whatever data or maybe whatever responses that you get. And if you notice any anomaly, don't forget to comment that in the comment section below. And so without much ado, shall go ahead and now just run the tests. Yeah, and as usual, you can see the tests are taking a little bit of time, so I'll just fast forward this from this point. Alright, now you can see in about 2 minutes we've run our 111 tests and all of them have passed. And so technically whatever I can assert is that whatever we've actually introduced today, all of them have successfully passed and all of them are working as we expected today. And so that's it for today's tutorial. If you find this useful, please consider sharing and give me a thumbs up, as well as if you have any question, you can actually comment it in the comment section below. And so until next time, see you in the next one.